Welcome. In this module, we are going to start looking at data warehouse operations. Alright, so how do we start operating a data warehouse? So what we are going to discuss in this module are understand staging area of a data warehouse system, look at how do we do verification of data quality, uh, get started with populating a data warehouse, and finally querying a data warehouse. So there are different types of querying that we are going to discuss. Mostly a set of group by sets, group by rollups, group by cube. So all of the data cube concepts that we learned earlier is going to be used here, and then finally end by looking at what are materialized views. Alright, so let's get started. We started this week by looking at the high-level data layers of a data platform, the 5 different layers. And then in the last video, we looked at the enterprise data warehouse setup, right? Understood how it needs to be modeled. So in this video, we are going to start implementing a enterprise data warehouse. So one of the things that we have seen is the high-level data layer can be implemented in multiple ways, right? So we've talked about the data storage layer. So in this diagram, we are also seeing something called a staging area. So let's try and understand staging area. Not all data warehouse architectures might have a staging area. It is depending on how it gets implemented. But we are going to talk about how a staging area can help a data warehouse architecture. Alright, so let's dig a little bit deeper to understand staging areas. A lot of data warehouse architectures tend to have staging areas. So staging area is an intermediate and a transient storage for your ETL processing. It's intermediate because it acts as a bridge between the source, which is your operational data systems, and your target, which is your actual data warehouse. It is transient because they are usually temporary. They are mostly used to optimize and monitor the ETL jobs. Alright, so they can be implemented in many ways. So one basic way to implement them is flat files plus Python. Alright, they can also be implemented as a bunch of SQL tables within a database, right? So within a database, a bunch of SQL statements can do the staging area. So they can be called staging, and then you have your production tables. So it can also be a database within the data warehouse system, right? So you can have a staging database within your data warehouse system. So there are several advantages of staging area. It basically decouples operations such as your data validation, cleaning, and standardization. So those can be shifted to the staging area. It minimizes corruption risk. So in terms of before we are loading data, it helps us to check and validate the data before it gets loaded into the data warehouse itself. It helps to simplify the ETL workload, because if you're not having the staging area, then a lot of work has to be done in the ETL pipeline itself, right? It also helps to simplify recovery of your data. So if the transformation doesn't happen, so you still have a data place where your raw data is being held. So let's look at some of the functions of a typical staging area in a data warehouse architecture. So one of the key functionality is integration, because it consolidates data from the multiple operational tables. So as we have seen, your data warehouse can be looking at data from all the internal operational system within an organization, but sometimes it can also look at external data sources as well, right? Both internal and external. Another very important function is change detection, right? Because you're loading data from operational databases. So it helps to sort of extract only the new and modified data. So after the first initial load is done, so your staging area helps you to understand change detection of your original operation data and extraction of only the new and modified data. It helps to schedule your extract, transform, load jobs, right? Because you can sort of schedule it on a daily basis or a weekly basis, depending on how much of data, at what frequency data needs to go into your data warehouse. And finally, a lot of transformation in terms of data cleaning and validation can be performed in your staging area, right? So handle standardization, as we talked about, across the operational data, take care of missing data, any of the duplicate records while you're bringing data from multiple sources, etc. And you can also do your aggregation and summarization of the data before you load into your data warehouse repository itself. So one of the key things that we see here is data cleansing and validation. So next we are going to look at how do we validate data quality. So what does data quality verification mean? So it refers to the process of checking data for different attributes. A typical data quality verification looks for 4 attributes: the accuracy of your data, completeness of your data, consistency, and currency, how latest current your data is, right? So there is a lot of advantages to doing data quality verification, because loading high quality data into your data warehouse changes the game of your data warehouse systems itself, right? Else you are essentially stuck with a lot of noisy data from your typically operational database are noisy, right? So here we'll see some of the advantages of high quality data. First, it enables successful integration of data to get complete and connected view of the organization, right? So only when you ensure accuracy, completeness, you understand the different aspects of your business process. So remember, in a data warehouse, our focus is on the business process, right? How do we successfully integrate pieces of data across different operational data for a particular business process, right? So it helps. Only high quality data is resultant in successful integration of data. So integrity of complex relationship. So it's important to remove all the duplicate records, etc. Else, when you do a lot of joins across tables, right, you are going to end up with a bunch of duplicated data, right? And if you want to look at the number of rows it returns, so only with high quality data, only when you remove all of these duplicate records, you are going to have data integrity when you are doing complex joins in your data warehouse query. It enables advanced analysis like your statistical model and ML. So a lot of the statistical model and ML is based on the quality of data, right? So if the more we understand the data and the more your data quality is maintained, the algorithms, you have better control over what kind of features that go into your machine learning algorithms, etc. So providing first, getting the high quality of data is a very important first step to doing any of the further advanced analytics process. And finally, by looking at all of it, high quality data essentially helps us to boost the confidence of our insights, right? Hence, the truly making your decision data driven, which is essentially the purpose of your data warehouse systems itself, right? So this is a very important part which often gets doesn't get highlighted enough, because the whole idea of having a data warehouse is to ensure that you have high quality data to boost your confidence on your insight. If it's low quality, then you are essentially doubting all the insights that's coming from your data warehouse itself. So when we do data quality verification, what are some of the data quality concerns that are there, right? So we looked at the 4 types of data verification. So let's deeply look at some of them. So first is the accuracy of the data, right? So the data in the source operational database and your destination system should match. It should make logical sense, right? You shouldn't have any sort of duplicated data in your destination system. Correct any of the typos with regard to your product category or your country code, etc., right? Because different operational systems could have evolved over different times. So it's important to be able to correct all of the typos, especially in terms of these categorical data, which would make a lot of difference when you are grouping your categories in your data warehouse. And any sort of mass alignment across operational data, right? So if you want to have dates in a particular format, etc., that is important to ensure that the data is accurate. The second is looking for data completeness. So we should be able to locate missing values, right? So missing values are typically null values which weren't captured in your operational database. So null value or void value. Sometimes because of when the data is not captured, they tend to get also replaced in some organizations as extreme values, -1 or 9999, etc., right? So it's important to locate missing value due to system failure as well. So your operational data essentially has a software system as a front end through which it's actually recording your customer data or your enterprise resource planning data, etc. So it could also be that, hey, you have missing data because your system failed at a certain period of time, right? So locating your missing data and understanding the reason why you have missing data, right? Is the customer not actually filling up information, or does the database not return because of some system failure? Only then we will be able to correctly substitute any void data with the appropriate value if needed as part of the imputation process during the transformation. Next is consistency. So any sort of non-conformance of standard terms, right? So sometimes across different operational data, you will see very common in enterprise are date formats, right? So one database has DDMMYYYY, whereas the other one has MMDDYYYY, or you have dates as your date and your short form of your month, etc. Similarly, product category codes or regional category codes, right? Location, there is a lot of different acronyms that get used, and even within an operational database, you might find different category codes during different evolution of your software as well. And units of measurement, probably if is it in the same metric system, right? And if there any, so it's important to ensure consistency of data between the operational data system. And finally, currency, which is keeping your data current, right? So avoiding any outdated information being loaded into your data warehouse. So whenever you're doing these quality checks, how do you resolve the aspect of bad data, right? So that is a continually improving process and it iterates. First, we have to locate bad data. How do you, so you first, let's say you have a lot of missing data coming from a particular operational database. You have to first detect it, right? Detect and capture, hey, this particular column is not getting. So then you report it, right? While you are doing this ETL process, you report so that somebody can investigate, hey, what's happening? So getting high quality data is only as good as how high quality data is there in your operational database, right? So that is a very important first step for creating your data warehouse. But only by starting this process of data warehouse creation, you will realize that you can go and fix a lot of operational issues of data collection in your operational database itself, right? So a typical way of correcting your data quality is you detect it, you capture it, you report it so that there is investigated and it's diagnosed, and then it is fixed by making sure that your data collection is corrected. So now let's look at populating your data warehouse. So populating a data warehouse is an ongoing process. So there is an initial load that happens once you've created a data warehouse. All of your data in your operational data warehouse is loaded into your in your operational database is loaded into your data warehouse. But every time your operational data is going to keep changing, right? So your data warehouse also has to keep current. So there is going to be periodical incremental load. In most organizations, this is a batch process. So this can be done at an end of a day or at end of a month, end of a week, depending on what is the use case of your data warehouse. So typically some organizations do require data refresh at a higher rate, right? So you can also think of batch as doing it probably twice in a day, right? Or every 4 hours or every hour. So even if you want real-time information, most organization may not really require really real-time updates, but it can be solved by doing sort of pseudo real-time, right? So you can do hourly updates to your data warehouse. Very rarely you might have to do a full refresh of your data warehouse if there is any schema change or some catastrophic failures, right? But they are typically rare. So in a data warehouse, we have also seen that there are two types of business data, right? So you have your fact table, which is your main business process. They need to be updated frequently because that is what is capturing the essence of your business process. So your sales data changes rapidly, right? So it has to be updated every day or at the end of the week, etc. Whereas your dimensional tables are categorical data. So it is storing only the context information. So probably your customer ID or your location. So they don't change as often, right? So you can see even between the fact and the dimension table, the update frequency will be very different. Fact tables need to be updated more frequently, whereas dimensional tables need not be, they are slow changing. They need not be updated as frequently. So what are some ways to populate an enterprise data warehouse? So today there are multiple tools that exist to automate the ongoing loading process, the incremental loads, right? So cloud-based data warehouse system have loading utility which is faster than loading one record at a time. So you don't have to take care. So if you're using a fully cloud-based data warehouse system, you can use their loading utility to fastly load all your incremental rows. So we can also automate the loading as part of your extract transform pipeline using tools like Apache Airflow and Kafka. So this is what we will do later in the course, right? How do we actually automate this loading process? Build our own ETL tools if it comes to it, right? So that is where we will deep dive into how does Apache Airflow work, and then your Kafka for streaming data, etc. Your enterprise data warehouse can also be populated using tools like Bash and Python and SQL to build your data pipeline, and it's scheduled as a cron job. So cron job refers to a command line utility that is typically used in software development process for scheduling jobs. Job is any sort of task, right? At the end of the day, hey, you need to capture all of the differences in your operational database and update it into your data warehouse. So there are several steps to prepare for loading your data warehouse. So first is the schema is model. Hey, what is the schema of your data warehouse? So what are your fact tables? What are your dimensional tables? How are they connected? All of it. The next is data is staged, which means data is pulled from multiple sources. The quality of the data needs to be verified, and then we do the initial load. So initial load, you have to instantiate your data warehouse, its schema, create your production tables. So typically when you create your production tables, you create your dimensional tables first and your fact table, and then you establish the foreign key relationship, and then you load the transformed and clean data. This is for your initial load. For any sort of ongoing incremental loads, right? So you can automate your incremental loads using script as part of your ETL pipeline process. You load data once a day, once a week. So typically this will depend on what kind of insight you're looking from your data warehouse and how frequently your data is changing, right? So not all enterprises require really real-time updates to your data warehouse. So it depends on what kind of analytics makes sense for your business. So one of the key things about your incremental ongoing loads to your data warehouse is need for accurate method to detect new and changed data, right? So only when you detect, hey, what are all the changed data in the operational database, then your incremental load is going to be efficient, right? Else you're sort of going to do a sort of every time think of it as a full refresh, right? That is not the way you do efficiently. So there is a need to accurately detect new and changed data. So how do we detect change? So changes are detected typically in the source database itself, your operational database. So these source databases are typically RDBMS systems. So in a typical RDBMS system, they do have capability to do change tracking to identify new, modified and deleted records. So often you must have seen in some of these tables, if you have used your enterprise database, you have a created day, your updated date, timestamps in tables, right? This is typically used to keep track of records that are newly written, that got updated, so that at the end of the day, you only look for records that are created on that particular day or that got modified during this particular day. Another way to detect change is do like a very brute force way of comparing your data from your original source system and your staged data, right? So you sort of compare and any sort of delta, so you can write scripts to find this delta difference and then load. So typically a data warehouse also undergoes periodic maintenance to archive data that is not used as often. So this is where we tend to call data as hot, warm and cold data, right? So especially when you are using cloud storage data. So because your data warehouse is a collection of your current data and historical data, and remember, in a data warehouse, we are also creating a lot of aggregate data, your snapshot table, your accumulated snapshot table, all of this, right? So it is going to get eventually pretty heavy. So it's important to archive your data, which may not be as current, right? Because think of your data warehouse as a long going project, right? So scripts can be written to archive older data to less costly storages, especially if you are deploying it on the cloud. So that is why we typically in organization we talk about data which is hot, which is of a lot of value. There are a lot of analysis, exploratory analysis, dashboarding going on the hot data, which is typically the last 6 months to 1 year of data. Then you have warm data, which is your previous year, right? Because you want to look at sales trends, etc. Whereas cold data is data probably already 2 or 3 years old, which may not be relevant in terms of tracking sales trend. Especially this has become very valid from with the COVID era, right? Because your patterns could change. So once you have populated your data warehouse, next you have to query your data warehouse. So let's look at some of the querying options available. So let's talk about different ways to query the data that you have now populated into your data warehouse. So if you remember, we talked about data cube, right? Which is a fundamental unit in which data is stored in a data warehouse because it's multi-dimensional data coming from multiple operational systems. So you have what are called cube and roll-up queries, which are easier to implement to provide summary report. So we will take examples of each of it as we go along. Then you have what are called materialized views, which are stored tables that are used for reducing load on complex and frequently requested views on large data set. So you can create view which joins a lot of these tables and just creates it so that you can query on the materialized views. Right? So query materialized views are faster than querying the underlying table itself. And then you also have techniques where you combine your cubes and roll-ups with your materialized views to enhance performance. So now let's look at this cube and roll-up queries. So there are different ways. Typically when in a data warehouse you are looking to understand the relationship between multiple tables and aggregating the data, right? So we saw the example of a group by clause when we looked at SQL statement. So in data warehouse we do grouping sets, grouping cube or grouping roll up that allows us to easily create any of these aggregated subtotals, grand totals in a variety of ways. So these operators are used along with your group by operator. So we'll see individual examples of it. I'm just summarizing it as a starter. So the grouping sets operator allows us to group data in several different ways in a single select statement. The roll-up operator is used to create subtotals and grand totals for a set of columns. The summarized totals are created based on columns passed to the roll-up operator. And then you have a cube operator which also produces subtotals and grand totals. So it produces these aggregated information for every permutation of the columns provided, because in a data cube you can sort of pivot data from multiple. So every combination of columns provided is being used is provided by the group by cube operator. So let's see some examples. So just a very quick refresh, right? So in this slide you can see your fact billing table, which is your fact table, and then which has your bill ID, customer ID, month, date and bill amount. And then you have your dimensional customer ID and your dimensional month ID, month table. So we when we did SQL, we did group by, right? You can group by year, right? So you can, if you select year and category and sum all the billed amount from your fact table and you do the specific join, right? So fact table customer ID is dim customer ID. Fact table month ID is dim month ID. Then you are grouping by your year and category, right? So which means what will come is, so you are going to have a table which will give you the year, category and the billed amount, right? So this is how your output will, then you have your billed amount, right? Which is grouped by the year. So let's say 2013, 2014, 2015, and within the year you look at different category. That is essentially how your group by clause works. But when you are doing group by, you cannot do different combinations of your year and category. That is why the grouping sets, roll up and cube comes into picture. So let's take an example of group sets. The same data set, if you are trying to look for grouping, right? So you're doing your left join typically, but you do group by grouping sets, year and category. So what that does is, it basically unions the group by year and group by category, right? So you will have essentially a set of rows where you have only the year value, right? So you have 2013, 2014, 2015, and then one where here category is customer category. So it could be home office versus corporate information, etc., right? So your grouping set is, the equivalent is essentially a union of group by column 1, union all group by column 2. So another slightly advanced way of doing group by is your group by roll up, right? So what happens in a group by roll up? So this is your syntax. You essentially do your joins and then do your group by roll up, year and category. So what happens in a group by roll up is you are doing group by the grouping sets. So different combinations of columns. So you have so year, category, just year, right? And then your null set, which is aggregates all of your data across year and category. So you can sort of see that it's sort of rolling up. So you will first have aggregation of all your bill amount, then only using your year, then using year and category, right? So you can see It's sort of an incremental aggregation, right? Subtotal and aggregation value. And the final thing is your cube. You can also do a group by your cube information, right? So the syntax is this: group by cube, year and category. So the equivalent grouping that happens in this case is all permutations and combination. So remember, in ROLLUP what happens is you have entire aggregation, then the first column and column 1 and column 2, column 1, 2 and 3 if there are more than 2 columns, right? But here you will have entire aggregation, column 1 separately, column 2 separately, column 3 separately, then 2 combinations of column 1 and 2, 1 and 3, 1 and 2 and 3, right? And 1, 2 and 3, right? And different combination, especially for multi dimensional data. So this helps you. So typically a cube, group by cube, gives you lot more rows than your roll-up or your sets, right? Because it essentially looks at different combination of your value. Because your data is optimized for data retrieval, these cube and roll-up queries tend to work much faster in a data warehouse system. So finally, we are going to take a look at materialized views. So materialized view is a snapshot containing results of a query, a local read-only copy. So it's typically used to replicate data. So you pre-compute and cache expensive queries such as joins and aggregation in a data warehouse as a materialized view. Then you have the option, so then you can essentially refresh these materialized views, right? So you can either refresh never or refresh upon request manually or scheduled, or refresh automatically at every statement. And you can use these material views to be queried, right? So they can be queried, so it's safe to work with them because it will not affect your source database. So let's take an example to understand it. So in this example, we are creating a materialized view in some cloud data warehouse. Materialized views is called materialized view table as well, MQT. So you are creating a table country stats, right? So that is selecting country, year, billed amount, group by country and year. And then this is your materialized view that you are creating. And then you can refresh. So in a Postgres database, you can refresh this table, country stats, manually, right? So that it will go and fetch data from that particular fact table, etc. So that you can use, then you can query, you can do select star from your country states and do further analysis on it. Let's summarize all the learning of this module. So in this module, we took a deeper dive into the enterprise data architecture to understand the importance of staging area in that architecture, right? So it helps us to integrate data from multiple sources, to do quality check, do transformation before you populate your data warehouse. So we also looked at all of the considerations that we have to keep in mind while we program our ETL pipeline to populate your data warehouse. So once data is populated, we looked at how do we query your populated data warehouse and how we can use the data cube concepts that we learned earlier, right? Group by using your grouping sets, your roll-up, cubes, etc. in order to extract this aggregated information from your data warehouse. We also got introduced to materialized views, which helps us to optimize your query by creating views that can be refreshed and queried upon. So please do take a look at all the assignments so that you can do a hands-on understanding of all the concepts that we saw. All right. I will see you in the next video. Thank you.